Right, so the Mikado. Some of you may know this, an opera from Gilbert and Sullivan. Why am I talking about this in a technical talk? Well, there's more, because here we have a box of sweets called Mikado. Then we have a book called The Mikado Method. And we have this game, sometimes called Pick Up Sticks, but sometimes called, yes, you guessed it, Mikado. And this is a picture of the ancient emperor of Japan. And what's another name for the emperor of Japan? Yes, also the Mikado. Okay, these things all have something in common. You can probably tell what it is. But why am I showing you all this? Well, first of all, which is the bit that we are probably most interested in this talk? You might guess that we're interested in the Mikado method. It's absolutely true. But why is it called that? I'll actually tell you what it is. It's called that because it's based on this game, the pickup sticks. And the reason it's called Mikado is because the main stick in the game is called the Emperor stick or the Mikado stick. Interesting. And the sweets, by the way, they get their name from the pickup sticks. The game itself gets its name, obviously, from the Emperor of Japan, the Mikado stick, named directly after that. And of course, the opera also gets its name directly from the Emperor. So, okay, I'm torturing this a little bit, but now you can see we have a bit of a map of dependencies here, and we can disentangle that a bit, and we can see what derives from what more cleanly. And you're probably guessing this is like an analogy for our code. Our code often is a mess of dependencies which are not always immediately obvious, but if we do a bit of work, we can disentangle and we can see what they all are. What's this got to do with the Mikado method? The Mikado method is really just a slightly more formal way of doing exactly that. And it's particularly useful if you're trying to test a legacy code base. Legacy code base, of course, being a code without tests. Well, as long as you've got something around that, and maybe you can use approval tests or some other sort of end-to-end testing to give you some sort of signal if you've broken anything. If you want to make a change in the code, according to the book, what you do is you run a series of experiments. You reach in and you try to make the change that you wanted, and then you see if you broke anything. Doesn't matter how you broke it, but if you broke anything at all, well, go and see what you broke, and now roll back. Try to disentangle the dependencies at that level, run the experiment again. If you've broken anything, take another step back, roll back, fix, repeat until you get to that most or that least dependent change. And once you've done that, you can then repeat those fixes in reverse until you get back down to the point of the code you actually wanted to make the change to, that sort of emperor change, the Mikado change. So a bit like the pickup sticks. You pick up a stick without disturbing the other sticks until you get back down to the Mikado stick. First one to get there is the winner. If it sounds like a really slow and painful way of making changes to code, you're not wrong. This is like something you roll out when you don't really have any other choices. And again, working with legacy code, that's often the way. And it's something that we probably would do more or less organically anyway. You probably found yourself doing something like this before. Why write a book on it? Well, read the book, you'll find out it's just a nice way of formalizing it and giving you like some of the trade-offs and other things to think about along the way to make the best of a bad experience. So check out the Mikado method.